Okay, now to complete this example, over here if you see, so we found this RE, okay, and RE was from this equation from VB plus VBE plus VE, right? Okay, and then we put the values, we get this one. Okay, so anything you value you get RE, remember it will be very small value, it will be in ohms. Okay, so R1 is known now, R1 is 56, R2 is known, which is 10 kilo ohms, right? Okay, and beta is given as 200, right? And RE1 is 68, you found RE prime, so R in total is determined. You put the value over here, so this is done. Okay, what about RL? RL is 8 ohms over here, so you can put the value of R, this is done. Okay, AV square is the product of the gain, or is the square of the gain. Okay, now remember we have two active devices, two type of transistor. One is this one, which is our common emitter, and the other one is Darlington pair. So I need to calculate, sorry, from here I need to calculate first a gain of this. I can call it as AV1, okay, and then I can call this as AV2. okay, I will take the product of these two, and whenever I have the answer, okay, which is equal to AV, let's suppose AV total, okay, AV total, okay, I will make the square of this, okay, the square of this. So this one, this is shown over here. So okay, now so what is the gain of common emitter amplifier? This one, okay, so the gain over here is defined as RC by this equation. Remember this equation, RC1 divided by RE1 plus RE prime. So RE prime is already determined, this one, this quantity put over here. Okay, RE1, okay, this is 68 ohms. Okay, remember if there is no swamping resistor like this one, so there is no need of this RE1 then. Okay, but if there is a swamping resistor, so because of the swamping resistor, the AC current finds this way, like through RC. That's why RE1 is the effective resistance in the emitter branch. Okay, and so the only thing that is unknown is RC1. Now remember, RC1 will be the effective collector resistance, okay, the effective collector resistance, okay, over here at this point. So okay, so how you can calculate RC1? Okay, so RC1 would be equal to what? It would be the resistance connected at the collector point. So RC is one type of resistance that is connected to the collector of the transistor, and then you need to find equivalent resistance of this network, this okay, okay, so that will be parallel to RC, so it will be R3 parallel to R4 parallel to R in base of these Q1 and Q2, this one. Okay, so I can over here I can see, I can write this as R1, okay, R1 is actually R3 over here, so I put the value 5.6, okay, 5.6, and then what is R2? R2 is 22, so I can put the value 22. What is the value of beta square? So it's 200 square. RE prime, what is RE prime? RE prime is over here, you need to calculate. So again, what you have to do, you have to apply KVL in this loop, okay, so it will be VB, okay, VB plus, okay, 0.7, okay, so I can write this as VB equals to, okay, 2 VBE. Why? We have two junctions, one from here to here, and then again one from here to here. 2 VBE and plus VE, okay, VE over here. So VE is somewhere over here. This is your VE, this is VE, so I can write this as VE, and this is your VB, so basically this is your VB. Okay, so you put the values, okay, and then we'll from here I can calculate what I can calculate IE. And once I have this IE, okay, so I can find out the small resistance, which is RE prime, which is 25 millivolts divided by IE. So this RE prime is for this one, okay, RE R1 is for R3, this one, okay, R2 is over here for R4. Okay, so once this is done, so basically everything is known. And RE, remember this one will be R3 parallel to this 8 ohms resistor. Okay, so this is done. So once this R in total is determined, so remember it means that R in total is basically a resistor, okay, from this end, so this end from there to here I can spawn it. Okay, you can say that you can this represent the whole network by an equivalent resistance. Okay, so equivalent resistance which is given by R in total, okay, which is given by over here by this equation. So it means that at the collector of Q1, okay, so I only thing is the total resistance will be RC parallel to R, this resistance, this one. So I can write this R in, okay, of R in total, T for total of the Darlington pair. Okay, so over here you put the value, this is calculated. Okay, RC is known, Rn is known by this equation now, and we can get this RC1, okay, which is actually this is RC1, this is RC1. Okay, then you put the value, RE1 is known 68 ohms, RE prime Q1 it is known from the equation you calculated, so AV1 is known. Okay, so over here this part is done. Now AV2 is the gain of this Darlington pair. Now by definition the Darlington pair gain is given by this, okay, now by this relation. So normally this RE is assumed to be very small, so I can ignore it, so I can write this will be RE, okay, and divided by RE. Okay, so again I can say this will be equal to 1. Okay, so it means that this is also known, this is now equal to 1. So I can now make the square of this. Okay, I will scale the square of this and put in this equation. Okay, in this equation, so I'll get what AB. Okay, AB. So this is the method or the way to calculate the power gain and the voltage gain. So the voltage gain is basically AV1 and VA2. Okay, this is done. Thank you.